After World War II, the modernization of the Japanese National Railways, JNR, progressed starting with the core main lines of its transportation network, the Hokkaido and Sanyo routes. Following the introduction of large steam locomotives, electrification advanced rapidly, completely erasing any pre-war traces. Meanwhile, the Tohoku region lagged behind in modernization. Old passenger coaches retired from the Hokkaido line were repainted in a style reminiscent of the Series 20 coaches, and the first limited express in the region, Hatsukari, was launched. However, as the train was hauled entirely by steam locomotives and lacked air conditioning, there was a stark contrast between the service in Tohoku and Hokkaido, fueling growing demands for modernization. Eventually, Japan's first limited express diesel multiple unit (DMU) service debuted in the Tohoku region, replacing the Hatsukari with the modern Kiha 81 formation. This eliminated air conditioning issues and smoke emissions. In the following year's Sanrokuto timetable revision, limited express DMUs were also deployed in Hokkaido. Through the combination of Hatsukari, the Seikan Ferry, and Azora, the travel time between Ueno and Sapporo was finally reduced to under 20 hours, a groundbreaking speed improvement given the underdeveloped state of air transportation at the time. Hokkaido, once a paradise for large steam locomotives, transformed into a kingdom of DMU limited express and express services operating across the region. Compared to Shikoku, which was also considered a kingdom of DMUs but lacked limited express operations due to short operating distances, low transportation demand, and steep gradients, Hokkaido received preferential treatment. Its limited express DMUs were mass-produced and introduced alongside limited express services. However, railway modernization in Hokkaido soon stagnated. While the Series 181 DMUs gradually increased in service throughout Honshu and demonstrated high-speed performance on electrified sections with strong tracks, allowing their deployment even in gradient-heavy Shikoku, no new DMU series was developed for Hokkaido. Despite Hokkaido's robust railways, which could accommodate large steam locomotive-hauled heavy freight trains due to coal transportation demands, the financial difficulties of JNR made further improvements unrealistic. Around the same time, the Series 381 tilting EMUs entered service, and experimental trials of the Kiha 391 began to explore high-speed operation on non-electrified lines. Travel time reductions were simulated for the Hakodate-Sapporo route, but these remained purely theoretical. Ultimately, gas turbine-powered cars faced numerous challenges, leading to the cancellation of the project, while tilting EMUs were only mass-produced for DC-powered lines. Electrification costs proved to be a major obstacle, leaving the introduction of such trains infeasible and eventually forgotten. JNR's worsening financial situation and deteriorating labor relations further prevented any active efforts to improve high-speed services and customer experience on regional lines. As a result, these routes remained neglected for extended periods. During this time, the rapid expansion of expressways, highway bus networks, and the growth of airline routes dramatically reduced JNR's position in both inter-Hokkaido transportation and long-distance services to the Kanto region. Passengers no longer had expectations for JNR, particularly as the outdated Series 82 DMUs continued to operate at conventional speeds. As the Series 82 aged, operational costs increased not only in customer service but also in maintenance, driving urgent calls for cost reductions. Thus, JNR finally took decisive action and began developing a new series of limited express DMUs specifically for Hokkaido. Push-pull train configurations were considered, but due to the substantial weight of the motive cars, deployment was limited to certain routes and often required speed restrictions. Additionally, a significant portion of space was occupied by the machinery room, forcing either a drastic reduction in passenger capacity or the adoption of a locomotive-style setup without a passenger compartment. This led to an increase in the number of cars in each formation. While concentrating traction power in specific cars could reduce overall maintenance costs, it presented operational disadvantages. Ultimately, it was decided to maintain the conventional distributed power DMU configuration. By this time, a decade had passed since the Series 181 had entered service. Over that period, the Series 181 suffered from mechanical failures due to its novel engineering concepts and frequent engine trouble caused by prolonged high-load operations. As a result, its original output of 590 horsepower had gradually been reduced to 550 horsepower. Later, as JNR stagnated and high-speed operations became unnecessary, further reductions in engine output were implemented to ensure reliability, diminishing the defining characteristics of the Series 181. Based on operational experience from the Kiha 65, which used direct drive gears under high-load conditions, as well as the success of the Kiha 66 and 67 series, it was determined that DMUs equipped with the DML30 engine series could realistically operate at 2000 rpm with an output of around 500 horsepower. The new limited express DMU for Hokkaido would follow this configuration. With these considerations in mind, the vehicle design was guided by the following fundamental policies. Achieve running performance equivalent to or superior to the Series 80 DMUs. Since no track improvements were expected, speed increases would not be feasible, and thus the maximum speed would remain at 100 km per hour. Instead of incorporating a dining car, onboard sales areas were expanded to accommodate passenger needs. The train formation was designed primarily for operations originating from Sapporo, with fixed formations of either 7 or 10 cars. For this reason, the leading cars were built without a pass-through door, adopting a slanted front-end design featuring a high driver's cab. Unlike the bonnet-type front shape seen in early Kodama-style limited express EMUs or the signature front-end design of electric limited express trains from the Series 581 onward, this new design introduced a fresh visual concept. It also marked a return to the non-pass-through high-cab style first introduced with the Kiha 81, significantly transforming the well-established image of limited express DMUs, which had been reinforced by the Kiha 82. The service power supply system was the same as that used in the Kiha 181. While 2 generator sets were sufficient for passenger services, the required power for cold weather measures increased substantially. To ensure sufficient power availability, in a 10-car formation, a Kiha 184 unit equipped with the same generator set as the leading cars was included in the middle of the formation, similar to the previous arrangement where a Kiha 82 was inserted in the middle. This car shared radiator system characteristics with the leading cars, reducing passenger space to allow for floor-mounted radiators. Large radiator ventilation openings lined the sides, giving it a sturdy and heavy-duty appearance, though it inevitably resulted in fewer available seats. The additional power capacity was utilized to implement extensive snow and freeze-resistant measures, ensuring optimal performance under Hokkaido's harsh climatic conditions. Axle springs of the middle bogies were covered with rubber to prevent direct exposure to the outside air, reducing the risk of snow and ice buildup that could eliminate their spring effect. Additionally, the horizontal beams of the car body frame and bolster beams of the bogies were equipped with electric heaters to prevent snow penetration and solidification, which could deteriorate ride quality. For 2-axle drive bogies, the second propulsion shaft, which passed through the bolster beam, was equipped with a fan blade to prevent snow accumulation. Furthermore, electric heaters were installed in the braking system, placing strong emphasis on countermeasures for running gear operations. In braking systems, electric heaters were also integrated, placing significant emphasis on countermeasures for running gear. Such extensive cold-resistant and snow-resistant measures required substantial electricity. However, as mentioned earlier, in a 10-car formation, 3 power engines, more powerful than those in the Series 80, were installed, ensuring ample capacity to meet these power demands. Around this time, seat comfort in limited express DMUs finally began improving. Standard class seats adopted the same seat pitch as the Shinkansen, and simplified reclining seats were introduced, gradually addressing the long-standing perception that standard cars were inevitably cramped, uncomfortable, and lacking in seating quality. Glasswool insulation was inserted between the car body walls to improve thermal insulation and reduce noise. Air suspension was reinforced for better lateral stiffness, while car end dampers were adopted to suppress yawing, significantly enhancing ride quality. Furthermore, the coolant system was upgraded with antifreeze, eliminating the inefficiency of conventional DMUs that had to idle overnight or continuously preheat using water heaters. This innovation allowed engines to be shut down in winter without the risk of freezing damage. These measures ensured that while the Series 82 had suffered frequent water-related issues in winter, the Series 183 remained trouble-free, earning praise from railway personnel. Over time, the cold and snow-resistant performance of the Series 183 continued to excel, and its reduced engine output contributed to fewer mechanical failures, further enhancing its reputation as a reliable vehicle. To prevent fires caused by overheating of the engine and hydraulic transmission, an automatic fire extinguishing system was installed. Passenger compartment fittings were made from non-combustible or fire-resistant materials, integrating countermeasures for train fire safety, a concern raised following the Hokuriku Tunnel fire incident. Unlike the fully automatic transmission used in the Series 181, gear shifting in the Series 183 was manual but semi-automatic, adjusting automatically based on engine RPM and speed. The Series 181 had faced occasional difficulties with fully automatic shifting, leading to later modifications such as the addition of a kick-down push button. Some operators preferred manual control to better adapt to specific running conditions. Despite these improvements, concerns remained regarding the vehicle's overall performance. Efforts were made to reduce weight, but the cold and snow-resistant structure, combined with reliability improvements in the engine and other equipment, led to a considerable increase in mass. Although axle loads never reached 13 tons per wheel, the Series 183 was heavier than even dual-voltage EMU motive cars with heavy transformers, exceeding the Series 181 by 2 to nearly 4 tons. As a result, much of the enhanced output was offset by the increased weight. Given these circumstances, the Series 183 entered service with only a few prototype formations as the limited express Azora. However, only 2 Keiha 183 units were available as reserve cars. If middle cars were sent to the workshop for maintenance, the non-pass-through Keiha 183 could not be substituted. This was particularly problematic if the Kira 182 entered the factory, affecting passenger service quality. In such cases, operations reverted to conventional Series 80 formations. Despite tight constraints in vehicle availability, the Series 183 maintained stable operations under these limitations and was highly evaluated for its consistent performance. The cold and snow-resistant features were particularly well received by railway personnel, as they resolved many issues that had plagued Series 80 DMUs, making the Series 183 a highly anticipated train. However, the cautious output settings, heavy equipment, and unchanged maximum speed of 100 km per hour later became points of concern. At the time of the Series 183's introduction, JNR was on the brink of financial collapse. Amid these dire circumstances, the train was designed more as an emergency measure to sustain operations rather than as a long-term solution. As privatization became increasingly imminent, recognition grew that the railway's survival depended on significant improvements. Thus, efforts toward high-speed operations in Hokkaido gained momentum. However, the Keiha 183 had not been originally designed for such a mission, making it an unexpected challenge. Nonetheless, as circumstances shifted rapidly, various adaptations were implemented in response.